Hi, I'm Chris, and in this video we're taking a look at the January 2015 SAT Section 2, which is the math section, question 17. This is from the grid-in questions. So 17 is going to be one of the harder questions in the section. In my opinion, for what it's worth, I think it is the hardest question in this particular math section. So let's take a look at how we can tackle a question like this. They tell us that x plus 2 times x plus a equals x squared plus 5x plus b. And in the question it says a and b are positive integers and they want to know the value of b. And they say that this is true for all values of x. So for a question like this, I'm going to put something up on the board quickly and then I'll erase it. But I want us to appreciate that this is actually just going to be a slightly more complex version of this kind of idea. If you saw something like this, you might look at this and recognize, okay, well, these x terms are like terms, and then these constants are like terms, and you could set each one equal to each other. So when doing that, you would get a equals 4 and b equals 3. A goes before the x, 4 goes before the x. B is on its own, 3 is on its own, so that's how we can make that relationship between a and 4 and b and 3. We're going to do something very similar in this question. It's just going to take a step to get there, and it's going to visually look a little bit more complex, but it's this same basic idea. So let's try it out on this one. I'm going to go ahead and erase this for the moment, and we'll take a look. So first off, we want to make this left side of the equation look more similar to what we see over here on the right, which means we're going to have to FOIL this expression, and that will give us x squared plus ax plus 2x plus 2a equals x squared plus 5x plus b. Now here's where we're going to treat this the same way we did in that other example. So any like terms we want to combine or set equal to each other. So here, first of all, the x squared terms, when you subtract x squared from each side, those cancel out. So that'll make things look a little bit more neat and tidy. Right off the bat, we can get rid of those. So now what we're going to do is we're going to set everything with an x equal to each other, and then we're going to set everything without an x equal to each other, and we're going to see if we can simplify from there. So whenever you see these types of problems, we're going to have ax plus 2x equals 5x, and then separately, we're going to have 2a and b equal to each other as well. Now we can try to go ahead and simplify here. To solve for a, first of all, everything has an x, so if you divide throughout by x, you can cancel out an x from every single term, which means you're left with a plus 2 equals 5, and if you subtract 2, you get a equals 3. So now we have a numerical value for a. We can bring that over to this next part of the problem. 2 times a is now going to be represented as 2 times 3, which is 6. And so the correct answer for b on this problem will be 6. So again, the takeaway here, even though this is a complex example of it, first of all, try to make both sides of the equation look as similar as possible. Next, set any of the variable terms, terms with x's in them, equal to each other. So ax, 2x, and 5x we can set equal. And then set any of the constants, or numerical terms, 2a and b equal to each other. Now the one thing that trips people up on this sometimes is when we say constants, when we say numerical terms, a lot of people say, wait, but that has an a, that has a b, those aren't numerical terms, those have variables in them. By definition, a variable means that it could be any value. So in this problem, when it says that this is true for all values of x, that means x is a variable. But a and b are specific values of positive integers, which means that they're not variables. We just don't know what those values are, but they in fact do represent constant numbers. And that's one of the distinguishing features that makes a problem like this visually so tricky, is that they do have letters representing constant numbers and letters representing variables. But if you remember, x's go together, everything else goes together, set everything equal, plug in and solve, then you should be in good shape. For more, please feel free to check out our other videos, and thanks for watching.